So I don't know if you see the presentation right now. As I mentioned, thank you all for being here first. We really like to take the time to talk to communities like you guys who have worked so much in robotics before and to present to you so what we've been working on for the past almost 3 years now. And yeah, the presentation, as I mentioned today, what we are going to do is just a quick presentation of the company, who we are, obviously French from the accent, but more about the company itself, the robots, and then we'll do with Maël and Miroka a demo working with the robot, and then we'll take the time to take your questions and try to answer them as much as we can and as precisely as we can. So, to start, as you know, robotics have been evolving a lot in the past few years, and what we've seen is that a lot of robots look the same. Even in the past few weeks, there's been a lot of announcements, and all companies took the same principle at heart, doing a bipedal robot. Obviously, when you're doing humanoids, you think human, so you think bipedal. Doing a robot without a face, doing them all titanium looking. And we thought it wasn't the right way to do it. So 3 years ago, we started by doing characters. So we've been working with animation companies and designers to first start from the character to bring more to the interaction with the robot. And that's how we developed the design that you see on the left, here, Miroka. And in our story, what we are doing, in fact, is these beings, Miroka and her brother, Miroki, they are beings of imagination in a digital world. And our work as robot experts, not me, but the rest of the team, is to build them kind of spacesuits for them to inhabit the physical world. So we see really these robots and these platforms as a continuation of the digital environment in the physical world. This new design allows us to really go, as I mentioned, deeper, and it stemmed from experience. As our founder, Jérôme, that some of you may know or may have met before, was one of the co-founders of Aldebaran, also known as SoftBank Robotics, for a few years. And so working and developing Naos and Pepper a few years ago. And so when he started Enchanted Tools in 2021, we wanted to go deeper into the tech, but as I mentioned, the characters. And this is really the next step for us. A lot of guys here and girls are from not necessarily robotics experts, but a lot of them are from SoftBank or /Aldebaran. I am one of them. Yeah, so for us, a lot of experience stems from that, wanting to push the boundaries of what we could do. For that, we wanted three principles and three core principles of the robot was to do a robot that was friendly. Again, doing a real character with a retroprojected face meant that we could push the way we showed animations and emotions on the face of the robot, as you'll see in the demonstration, of course, and also what we call the animal interaction. So all the things that when I get closer, the pupils of the robot get bigger, the fact that the ears are moving like you see right now, showing a lot more emotions, and so deepening the connection and the level of discussion and interaction we can make with the robot instead of just having colors in the eyes like some others. The second thing we wanted to do and to address was the simplicity of the robot itself. That's meant several things. First, it's a simplicity of use and simplicity of development also, as we'll talk about more in the demonstration, but also in a simplicity and a different way of thinking in the design. The ball bot that I heard mentioned when we were just starting is one thing. For us, it means that, as you can see here, it's really simpler to move around, so it means more compliance in different environments. It also means simpler mechanics, as we are only using 3 motors on the ball instead of like 20 plus we would use with having a bipedal robot. It also means then cheaper cost, because we are not using as many motors again, and also a simpler use, as the danger with all these robots that are 6 feet plus and a few 100 pounds bipedal robots is that when you push them on the side, they can be quite dangerous. While here, you just have to push the robot and it will move back in its place. Brings all different challenges, of course, but really we were trying to solve the simplicity again in this type of environment. Another simple thing that we are using is the runes. They are small Bluetooth buttons that we code with behavior. We'll show them what they do, and you have one here. Perfect. So we'll display what they do in the presentation, and there's a lot of behaviors that we can code with them, meaning a rune can be a person, it can be a location, it can be an object, and from there, we can make actions out of this. And finally, the natural language. Again, that's something that we're going to tackle later. The final thing that we wanted to address, a bit too quick on the draw there, is the reliability. So the three main things and pillars that we're working on are the interaction with the robot, the navigation of the robot in the space, and thirdly is grasping. For that, we chose different design because grasping is really difficult. What we decided to do is to have these, thank you very much, these generic handles that we built, where you see the design is a bit specific for the robot to be able to recognize them. And as you can see here, there's also a rune attached, again, meaning that this is an object. Yeah, sorry, I attracted you there. So with this kind of simple design, what we can do is first be more reliable in the grasping capabilities of the robot. But secondly, it's also a way to announce and to show to people that are non-initiated with robotics that this is what the robot can use and other stuff they can't. So it's also a way of, in some environment, hospitals, for example, really showcasing and limiting the interaction of the robot and so the risks associated with the robots. With those, and you see them here at the bottom of the presentation, is with these handles, you can put them on several different things. Baskets, we have a tray there, but custom accessories, we have one that we use several times in children's hospital where the robot is handling a balloon. And so for these, please go ahead, guys. And so for these, it's really what you can imagine, you can make with a handle, and so for the robot to handle it. As you can see here, these are some just technical information about the robots that I mentioned. I will be able to send you a bit more. This presentation, I will be able to send you after the meeting. Dave, I'm sure that you're going to forward it to everybody. You'll find tech info, but more importantly, you'll see that the design you see here is quite different from the robot that we have today. And there's two reasons for that. The first one is that that's Miroka's brother, first of all, in the presentation. But secondly is that to talk a bit more about where we are here as a company today, this next to me is the first prototype that we built, one of the first prototypes that we built. They are a bit more than a year old now. What you're seeing today on the screen is the third wave of prototype that we are starting to manufacture now in our road to industrialization. They are still early access robots, as we call them internally, but you'll see that they are one of the stepping stones for us to go to the commercial release, and the commercial release will be Q4 2025, where the final version of the robot will come out. If you want a bit more time with the presentation, I will be able to send it to you afterwards. Go ahead, guys. What you see here, just a quick summary of all the things that all the environment and sectors that we could operate in and we are intending to operate in. Again, we are still early access today, but doing more and more POCs and experimentations. And at Dave's request, I wanted to do a small, not deep dive, but a shallow dive into a bit more of the technical information that we have. One of the first one is the development environment. So there's a few different steps. You want to cross? Yeah. Go ahead. It's late for us in France, so people are leaving the office. I apologize for that. We have several ways of developing on the robot today, really from the simpler means to a deeper dive. I'm sure you want to see the deeper stuff. We won't be able to showcase it today as we are still working on the levels of API control that we're giving. I will have more information about that in the coming weeks, so I'll make sure to send it your way when I have that. The first thing that we wanted to showcase is what we call internally the wizard. This is really a puppeting mode that we have for presentation or general use of the robot, of making him wave, making him do some stuff. You'll see also on the right-hand side there that you'll see better when I send you the presentation, a way also of seeing the LLMs and the way to control it, what the robot understands, and stuff like that. So this is really puppeting mode. You'll see also that we can control the robot and that we can see also the runes and how to handle them, configure them, and see all the information there. Secondly is the classic Python API. I think we have a video of someone coding a few things on it to show what it does. It is not someone typing really fast, but there's some information there. I'm sure a lot of you guys have already worked with Python, so won't go too deep into that. One thing we really worked on these past few weeks, and that is really important for us, is to have the simulator that is associated with that. So we have all the information, the degrees of freedom of the robot, so we can directly see the direct impact of what we coded on the robot. We have a limited floats, even internally at Enchanted Tools, and so it's a useful tool to go deeper and make more, even animations internally. I'm sure you have a lot of questions on ROS and other things like that. At the moment, it is still we can talk about it. I don't have anything to show you yet. Path planning and the level of navigation that we can do. We are working with Visual Slam today, and I'm sure you have a lot of questions on that. I'm not the guy to answer them, so I apologize for this. And finally, the runes. As we mentioned, they can be people, they can be places, and so it's also a way for us to handle navigation without using Visual Slam or in combination with Visual Slam. And that's the deeper, interesting stuff that we want to do. Is a rune can be a place, it can be also a place that we want to reject from the map. So it's a way of handling both the visual capabilities of the robot and this Bluetooth information for the robot to be able to go to the kitchen. And this rune is associated with the kitchen, so we can do a list of actions with these. This is it for my talk. It's been really long. I apologize for that. What we'll do now is just, with Maël and Miroka, show you a few things, mainly on the LLM side, as I know it's a big subject that you're interested in, and then we'll take all your questions.
Okay.
Go ahead.
Miroka, I think it's our time to shine.
Understood.
Okay, so do you know why today is a special day?
Oh, I love special days. Today is special because we get to present our work to the amazing folks at HackRobot. Plus, it's always a joy to share our enchanted adventures in robotics.
Thank you, Miroka, for being so joyful. So what should we do?
Absolutely. Sharing our enchanted adventures in robotics makes every day special.
What should we do to welcome our guests?
Exactly.
Come on, Miroka. I think you can do something to welcome them. Wow. So our friends are not here today, but maybe you can describe what you are seeing?
In this enchanted scene, I see a cozy and modern room with vibrant pink accents on the walls and ceiling. There are two friendly humans present, one closer to me and another further back near some stairs. The room is adorned with comfortable chairs, plants adding a touch of nature, and stylish hanging lamps casting a warm glow. It's the perfect setup for our friends from HackRobot.
Yeah, exactly. Thank you, Miroka. So maybe now you can entertain them a bit? Can you maybe tell them a story about someone that is hacking some robots?
Once upon a time on Morocco, a clever Miroka named Zillow discovered an ancient robot buried in the enchanted forest. With curiosity and determination, Zillow hacked into the robot's system using magical codes. To everyone's surprise, the robot came to life and started dancing joyfully with Zillow. From that day on, they became best friends and helped each other explore new adventures across Morocco.
Wow, that was a great story. Thank you, Miroka. So now I need to give more explanations. So maybe you can take a rest. Yeah, you will be back soon. Don't worry. So, hi everyone. I am Mel. I am a software engineer in the interaction team at Enchanted Tools. So, I was told you're interested into the LLM today, so I will focus my explanation on this. So, as you can see, Miroka is a lot talkative. It's because we connected her to a chat. No, sorry, not to a chat GPT, but to a GPT-4 or Turbo model. So it's the only AI that we have on the robot that is not actually embedded, but actually it's linked to other AI models that are all embedded inside the robot. So for example, you saw the voice recognition that is directly given to the LLM, but also we can give some vision stuff, and it allows us to put more context in what the robot will generate then with the LLM, and we also give inside the LLM the personality of the robot. So we are saying, okay, we want Miroka to be really with a lot of energy, to be really spontaneous, whereas Miroki might be a little bit shyer or something like that. But that's how the text is generated after that. And also we can add emotion. So maybe you noticed that when the robot is speaking, actually she is making some few face expressions. It's the LLM that also generates them. So that's the input we give to the LLM, as well as the action. When I say take a rest or go to bed, she's actually doing it because she understood it from my voice. Another stuff that is useful with the LM or without the LM are the runes, as we talked before. So here I have one. If I press it, it will wake up the robot. Nice. And also, so the robot knows that it's my rune. It's the rune that is named Mail. And so when I say, okay, now turn to Mail, she will actually follow me. So right now I have to say Mail. I can say follow me because we need more steps for that, but it's in the scope. Thank you, Miroka. It was all I wanted to show to our friends today.
You're welcome.
Okay, but you have to stay here because they might have some questions.
If you have some questions, we will try to answer them. We will answer them. And if we are not able, we will ask them to the robot directly, who will answer your questions. I just need to find the way to better hear you and the questions, and then we're good to go.
Okay, well, I'll start since nobody else is going. But yeah, feel free to unmute yourself and ask a question. But what happens if you lose internet connectivity and you can't talk to the GPT-4 model?
Yes, regarding connectivity. So today, I'll try to answer, and then Maël will correct me when I say wrong stuff. So today, we are everything is online. We need to be online because of the connection that we have with the LLM that we are using. Knowing that today we are using GPT-4 or Turbo, we in the logic that we have, we can technically put different LLMs. So if you have one that you would like to work with, we can, or we are agnostic in this type of yeah, go ahead.
Maybe I could add, so yeah, the LM is the only model that is not embedded. So the vision, the speech recognition, speech generation, it's all inside the robot. But also we are working to try to make some local LLM. So maybe it's going to be more like a SML, but customized with what we want the robot to do. And it will like turn as well on the robot. But you just have to remember, you got all the other models. You also have the face that is inside the game engine. There is all the stuff for the graphing and the navigation. So that's why we are still working on that to make it lighter, to be able to make it embedded.
Yep, exactly. So as well as working on a smaller embedded model, there's also a lot of stuff that is already embedded in the interaction part. So for larger questions, you'll see that the robot today takes a bit more time as it's checking online, the information with the LLMs. When it's quicker questions that we already know would be asked and are already embedded, the robot would directly tap into that for a quicker, faster answer.
Along the same lines, obviously with the connectivity, obviously in your office being Wi-Fi, are you looking to support mobile data connectivity for environments where Wi-Fi might not be applicable?
On a que le Wi-Fi ou est-ce qu'on a aussi la 5G et le 5G aussi? So as of this prototype, for 5G connectivity and everything, not yet. What I can say on record is we are working with some partners to have some non-Wi-Fi connectivity in the near future. So on these prototypes, no. For the future, nothing to announce yet. Thank you.
Could I ask a question about power? How long will the robot operate for between charges? And what about charging? Will the robot go and find its charger?
On peut le mettre en LLM pour lui poser la question. So la batterie.
Understood.
So for we can ask the robot for the battery life if you like. Miroka, what's your battery life today? Miroka, what's your battery life today?
My battery life is 4 hours when fully charged. My battery life is 4 hours when fully charged.
So yeah, twice the question, twice the answer. So it's not quite true yet. So 4 hours is the goal for the next version and the commercial release, and 2025 again. Today we are a bit more. I think it's 2 hours and a half, almost 3, and 1 hour for full charge.
Okay. And what about going to be charged? Will the robot go and find its charger and charge automatically, or does it have to be plugged in?
Yeah, so we are currently working on the self-charging functionalities. It's not as easy to do as on some other robots because of the ball bot, as you see, but we are working on it. And the way we are working on and the way we will handle it is the robot with the grasping capabilities will grab its charger by itself and plug itself in the back, as you'll see. What we don't see yet and what I can show you after is the design goal for the robots that we have here on the side. And that's really what the intended design we are heading towards. And you'll see that the battery is really in the back in a bit cleaner manner than what we have today on these, again, first wave prototypes that are a year and something old now.
I think you've got a couple of questions in the chat.
Yep. I will, for the first question about the PID for the ball and joint control, I have absolutely no idea. I will write the question down and come back to you regarding that. I don't know if we have a hardware expert just nearby.
Okay, we just catch an expert inside the navigation team, so maybe she will be able to answer.
Okay,
Okay.
Yes, of course. We're using a PIT for control, and we're working on more sophisticated methods like RL and reinforcement learning and other learning-based method. But for now, it's PITs.
And for the second question, yep.
So yeah, actually with this version of prototype, it will just fall. But before falling, the robot would say, okay, I have low energy, please charge my battery or switch it. So you know that the battery will be off soon. But on the next version, the robot is like properly turning off before the battery is fully empty, and there is a ring to secure the fall. So it will just shut off, but like gently.
Yep. In the design of the presentation, I will share with you after. I think we went quickly over it, but there is a ring around the design, even of the robots that we have currently just next to us. There's a ring, so the robot doesn't fall down. Indeed. The sensors that the robot has, several. So we are using 2 different cameras today. I can't give you the information on the cameras themselves because we are changing those in the new versions. So we are also using different lasers, matrix lasers on the base. There are a lot of other sensors like EMU.
Yeah, it's a Bluetooth technology.
Bluetooth technology there to recognize the runes, their angle, but also the depth and the distance of the runes. We have a lot of other captors and sensors there. When in the presentation again, there is some information on that. As we are again shifting from one prototype to the other, to even this 3rd generation now, things are moving quickly. So some information might be dated already. I will, in the presentation I will send you, we'll have the most up-to-date info. There's another question there. Not yet.
Now, what was the reason for using a ball instead of like a 3-wheel design? Huawei Robotics has a couple of robots that have 3 wheels in the base, and the robot can spin around and it doesn't have to keep bouncing itself. I'm just wondering what advantages would the ball have over a design like that?
There's several things. There are several technical reasons why we chose to use this ball-bot technology. One of the main one is because it looks rad. It's because it is impressive technology, and it's also a way to be different. And we want to push the technology also. So that's one of the reasons. Another one is really because several things. The footprint with a ball like that is a lot smaller. So it's also easier for us to go into some sectors that have specific constraints, like hospitals. One of our founder, with Jérôme, comes from the biggest innovation lab for an hospital in France. So that was also one of the sector we wanted to tackle, and so with specific needs. Second thing is that it's also really, this design is really battery efficient because the robot is using its weight. I mean, I'm not teaching you anything. I know you know that a lot more than I do, I'm guessing, but shifting the center of mass to fall in the right direction, and it's only controlling and resisting the fall, so it's really energy efficient. We could have made it with three wheels. It's true. We just wanted to do something a bit, different, that has not been made yet, and just cool tech.
Thank you. I like it.
It's one of the reasons for using the ball, but the sort of compliance. So I can see that it's just pushing the robot around. And I guess that's something you can do with a ball much easier than if you had wheels.
Yeah,
indeed, that's one of the things. And again, there's a whole compliance side of things. When I'm passing by the robot in a hallway, I want to be able to push it and not be flattened by it, I guess I would say. So that was one of the ways to do it. And just the fact that we can really move them around with, I can do it with one finger, as you see. That was one of the ways we wanted to do it. And again, looks cool.
Thanks.
You are welcome. Another question?
So looking at the design at the moment, and I may be reading far too much into what I can see on my screen, but it appears that you may actually have 2 hinge joints on the lower body?
Oh, you mean the joint there?
Yeah. And is there one above that as well?
Yep. Les joints ici, le fait qu'ils soient articulés.
They were supposed to be articulated at first, but I think it was discussed because
yes, it was. We at first we wanted it to be able to not crouch because it's on a ball, but be able to pick stuff from the floor. So that was one way of articulating the torso differently while still keeping the weight. It is really, really difficult to do. On the new ones, we have a more static form, here with a really center column, I would say. But it's one of the remnants on the first few prototypes of this tech that we tried. And yes, thank you. Someone is telling me in my here that we are working with one of the biggest French laboratories / universities in robotics in France called ISIR, that you might know, on specifically that, to bring it back in some capacities later. At first, we want to make sure on the new prototypes that we make something that is a bit more simple in design, but works well, and then go back to the difficult stuff.
Thank you.
More questions, written questions. I love those.
So there's one, I'll read it out, that there's one from the chat is, are the cameras arranged in a way to allow classic stereoscopic vision?
I will check. Yeah. So la caméra stereoscopique.
So yeah, we said we are 2 cameras. So the one on the head is more focused for the interaction and the grasping. So to be able to have like a real vision if the robot was really someone. And the second one is on the base and is used for the navigation. But so the camera is just aiding front of the robot, but we also have some other sensor, so time-of-flight sensors that make us able of using the obstacle avoidance, for example.
Thanks. Another question from the chat is, have you considered multi-robot cooperation? So yeah, if you have to carry or move something bulky or heavy, can you have multiple robots working together?
Yeah, so multi-robot cooperation. Yes. First, we are tackling that on the interaction side of things, that the robot recognize itself, it recognizes another robot, what it's doing today with the camera. But now we are working on making them interact in a way that is too proactive for humans. We don't want the robot to just keep chatting when there's not a human present. We need to find, fine-tune everything so the robots are not too chatty, but chatty enough, proactive enough. And that's one way we are handling things differently than the robots or robots before, is what we call the multimodal information that we're gathering. So the robot is not only checking, what we're working on at least is the robot is not only checking the voice, am I talking to the robot, which we are working on the robot recognizing with the camera that 2 humans are speaking, yes, but are they speaking to me? Are they not facing me? If they are facing me, if they are talking to me, then I need to answer. And also go deeper than that, and also think if there's 2 humans there and they are chatting, there's a pause in the conversation, maybe go there and try to interact. Regarding grasping and the fact that we would use the cooperation to carry something heavier, I don't think we tried it yet.
No, I'm not sure we want to do that, but yet we are more focused on making one robot work well. Yep. And then, yes, we want to make a fleet. So the robot should be numerous in the same floor, for example. And so when an order is given to a robot, it should communicate between all the robots that maybe there is one that is closer, just to like optimize the logistics and the movements around.
The question after that is for you, Maëlle.
Which one?
Does it have any kind of internal emotional model, and can it read face, body language?
I think there's one just above that we skipped.
That's one we skipped?
Yeah, the one that is highlight.
Yeah, we said.
You mentioned reinforcement learning. Does self-balancing use control neural network or something else, please? So no, I think the self-balancing right now is just like mathematics stuff, like really logic. But yeah, for the displacement, maybe for the slime and the obstacle avoidance, we will use more reinforcement learning for that. But just the stabilization, it's a mathematical model. Does it have any kind of emotional model and it can read face, body language? Good question, actually. So yeah, we started by doing like a mathematical model to mock the emotion, but we kind of ran out of time. So right now it's more the LLM that is managing that. But yes, we want to add more emotion and more impact on the, like if something happens in the environment, it should impact the robot. So for example, if someone falls in front of the robot, maybe the robot should look sad and it will affect his response for the next 5 minutes.
Or laugh.
Oh no,
We
we
don't
don't
know
want
yet.
another robot. This kind is not laughing at
Sorry,
people.
my bad.
Yeah, and so we are adding some models. So for now, the vision we have for the interaction is just body recognition. So the robot is seeing people as stickman. There's no face recognition, or the robot doesn't know which human is in front of him. It just knows there is a human. But we are adding some model to get some more features on the face. So is the person smiling? What is his mood? Maybe guess the gender, the age. But we are trying to go slow on it because we need to be friendly. So
Yeah. Another thing on facial recognition is that we are in Europe, and so GDPR is a big concern, and that we want to respect. That's also why we are careful about recognizing emotion and the way we handle this. We have the capabilities to do human facial recognition, and with the camera, of course, as you can do with your phone today. The way we handle it, because again, critical environment for some of these robots in healthcare or in retail. So the rune is one way of handling that, managing GDPR and being able to recognize someone of the staff, for example, as someone important that can give rules, be an admin, something like that.
Okay. There's another a couple more questions in the chat.
On robot designers, I do not know.
no, the robots were.
Yeah, there's one of the our internal art director. I think his title is even.
Yeah, actually, the story about the robots is Jerome that had the idea of making a character from another planet that is rolling on the globe. So it's all the enchanted part of Enchanted Tools. And then, yet we have a designer, like an industrial designer. So yeah, all the first drawings were made inside Enchanted Tools. So yeah, it was designed by the company.
We have a lot of older design in the office, in some like art display and everywhere in the office. Quite fun to see that. I can also send you another thing that I can send you with the presentation is we worked with Gaumont, which is a big French movie company, on an animation. Oh, yeah, great. On an animation movie with Miroki and Miroka. Thank you. It's a 3-4 minutes video showcasing what we talked about at the very beginning, the fact that they are beings from another planet going through a portal to inhabit the physical space. I will be able to send you this video. And I think if I'm not mistaken, you can also find this video on YouTube and see the story of the Mirokai. And yes, we also have 3 more people working with Robert, our art director in the industrial design team. Something I didn't mention that was in the presentation, but just quickly, today we are a bit more than 120 people, most located in France. Again, lovely French accent. But we have, I think, 20 plus nationalities today in the office.
So this is just me being nosy, and I'm sure Dave will appreciate it. Do I take it that a lot of this characterization came out of Spoon AI?
Yep, j'ai entendu. So today on the characterization, so the emotions that the robot is displaying. So we created them with what we call the animation engine, even the face and the faces that it can do, that we developed. Now the way in the LLM, the robot is choosing to action some faces and some movements and some skills and some actions, and so the robot taps into the database of different faces that it has. But we developed those beforehand. We are working, one of our sisters company that Jérôme is also a founder of, they are working on specifically digital characters. And so they really help us a lot in the facial animation and having, again, an extension of the Mirokai in the digital space for digital characters. And one way we want to handle that is also to have the continuation of the experience. If you're, I don't know, shopping for cars, you see one you like, there's a digital Miroka there helping you choose, and then find the same Miroka in the store after that. But so to answer your questions, not the development is made with AI, but we are using the LLM to action and tap into the database of developed faces.
I'm with you. Thank you.
To speed up the speed recognition, yes. Yes, we are working closely with NVIDIA on a lot of AI stuff with that. There's also a way to handle this. So you know that with LLMs, the way they answer is word by word, and so we can't wait for the full answer. Sometimes it's too long to wait. So the way we do it is we bring the word by word together to make a sentence. So every time the robot has a full sentence done, it will say it. So we have a limited latency that we can't reach, of course, but we are making it faster and faster. This is one of the older one. Please go ahead, Maya.
Yeah, actually, it's not the speech recognition that is low. The speech recognition is almost real time and really, really good. It's a connection with the LLM that is bad and the Wi-Fi out of office that is bad. So that's why it takes time. Yes.
There's a question about a developer program, whether you plan to have one.
Yes. Thank you, Richard. So a developer program. So today, we are still in early access industrialization phase. So the way we are doing it is the robot that you saw in the presentation, what we call internally the A2 robot, so the third generation. We are starting to produce them. We will have about 20 of those that we'll have in the next few months. About 10 of those we are in contact with universities for them to get them, and about 10 of those, and the rest will go to like more reseller partners around the world that want to start develop POCs and everything. We are working on doing a more developer approach. This is one also of this is one of the reasons we are doing this with you today, is we want to be closer to these types of communities and meetups and everything, and participate in that. We have been talking with Dave for a while now, and we want to do more. We are discussing doing probably a hackathon or something like that around this type of communities like yourself. Today we have nothing set in stone for a developer program, but it's in the works. And for this, yep.
Thank you for the Vivatech remark. It's really nice.
Yeah, thank you for the Vivatech.
And for the microphone, so for the first version, for this version and the next one, we have our array speaker seed. So they're integrated under the petal of Miroka. So yeah, it's a microwave for microphone, so it detects where the sound is coming around. But for the next versions, we plan to do our own mic card and everything, so it won't be the same.
Now a size Miroka would be amazing. Please don't give Jérôme too many ideas. We already hard at work on one robot. But yes, I agree.
Yeah, at some time we had like an internal project of making a table size Miroka, but
Does Miroka have any tactile sensors built into it?
Not this version. That's all I can say at the moment.
Okay.
But I hope my answer is still giving you some information.
Yes, indeed.
Thank you. Yeah, something I didn't talk about, and I apologize for that. So the early access is a bit different, and we can go deeper into the conversation at a later date. The goal for the end product, and please, I apologize, it's in euros, but for the final product coming out, again, end of 2025, the price tag will be, for buying the robot, will be 30,000 euros, and there will be a maintenance of, depending on the level of maintenance and depending on the LLM and connectivity like that, a few €100 per month for maintenance and everything, like a fee. One of the great difficulty in robotics, as you might know, is doing something that is affordable, and that was one of the great goals for us. So the 30,000 euros price tag is set in stone for us. It's one of the big objectives of the company, and we will make it happen. Do you have any other? Did we miss a question?
That's a good question, actually.
Yeah, for the
I think most hardware were concepted here. So except of the microphone and the battery, I would say we all conceive the thing inside the office, except the arms that are made from a partner company, Orthopus. They are based in Nantes, in France. And some species, like you can see at the neck and at the wrist, it's made by Poland. They are based in Bordeaux. So it's species that they give us in hardware, but all the rest, like the ball boat, was made at Enchanted, the head as well, and the face is software actually, but the head as itself, and all the full design, hardware design, I mean, also was made inside Enchanted Tools.
I got a question about, I don't know if I missed it or not, but about apps. Do you have a concept of having different applications, and can you share those applications? So I suppose some sort of community later on.
I'm sorry, I didn't get the question. I will get closer to hear better.
Sorry, I'm not sure if it's my mic. Apologies. Yeah, so if we have, once you start to sell it to distributors or partners, and they start to develop applications, how easy is it to share those applications and potentially resell those applications? Or that's not part of the model?
Great question. I love this question. Yes, it is not possible today because early access again. But yes, we are working on doing an application marketplace. So everybody that develops an app can put what they worked on. There will be a small approval process. But yes, we want to make it easy for people that have worked on software or people that are interested in getting off-the-shelf software and specific skills or behaviors to acquire them all around the world. So we are working on doing a software marketplace worldwide.
Okay, thank you.
There were a question about the sensile captor. So we don't have one on the robots yet, but I wish we will have some really soon in the next version. So we can do like what we call animal interactions. For example, if I touch the head and I'm like just giving a little pet, she would react if I touch her in the face. But also it would be practical if I want to move her, so she knows when someone is touching the shoulder, it might be that she will be moved. And it can also be used for what we call the social navigation.
Yep. For the end-all strays, are we inviting custom designs? Yes, we are. That's one of the way we wanted for it to be and that's also another thing that we might do directly in the marketplace. But yes, we are more than welcoming custom design. We are encouraging it.
With regard to this rune approach, which I think is really interesting, is there a limitation to the number of runes that the robot can handle?
Le nombre de runes maximum que peut gérer le robot. I don't think we've tried a maximum number of runes.
Yeah, we are usually in the office. We have like 30 runes, I would say, that are turned on each time. But I think we can do more. And I think the goal is to be able to do even more. So.
Okay. So I'm already thinking about applications. So.
How do we teach it to do tasks? Ah, ça c'est bon, ça j'ai fait.
Okay, so actually for now we are like making the, I don't know how to say it, but for example, to grasp a tray, we have like an action linked to a function, and so the robot knows that its action can be called like grasp the tray. So with the LLM, the robot knows that it's this action that it should do, but it's still like in like the low program. It's not like, okay, I'll show you how to grasp tray, do it like this. So for the grasping part, but maybe we will be able, for example, to teach him some moves like dance moves, or something like that. But for now, we are more focusing on just making each action well and launch the action at the good moment. Okay, I am not focused enough to read this long test story. Yeah, actually, it's I won't say a model, more like a system that we made and how we manage the action of the robots. So, and that, yeah, we are linked to the LLM, so the LLM knows what to launch, as I said just before.
Jetpack, please don't give Jérôme ideas again.
There once there were someone told me, oh, you can put some helium balloon to the robot so it could flow. Fly upon a crowd.
That's really good.
But no, we don't need to say that to Jean.
If you have jetpack technology, please reach out to me and we'll try to make something work.
You mentioned that when you're providing the robot, there will be a package to do with ongoing maintenance. But will there be any self-diagnostic capabilities built into the robot? And even to take it a step forward, to what extent would simple maintenance be able to be carried out by the robot itself on itself?
That's a tough question. So the robot's handling maintenance on itself, I mean, it's too early today on maintenance. It's really early days for us. We have a dozen robots internally, a bit more than that now. A lot of them are traveling for different trade shows and work. We have, I think, 4 in the US right now. For maintenance today, we don't really have the data to really work things out. I know that we work a lot in. Yeah, I saw the bouncing ball. Yeah, I saw the bouncing ball question. But on the maintenance today, it's really, really early days. We don't really have data to back anything, so we don't want to. I don't want to say anything and be wrong. I apologize for that. So maintenance is early days. We know that especially in the early access part, we will really work closely with everybody, all the universities and partners that we have, because it's also a teaching tool for us to know where and how robots fail and break. More than that, it's a bit too far ahead to start planning.
Sure, I get that. But I mean, obviously, as one looks to the longer term future, if you're going to put a robot into a practical environment, it's interacting with people, you've made the point about collision avoidance and so on, inevitably there is wear and tear. So if you're really serious about increasing the scale of operation, I think that's going to be a really important consideration. I appreciate it's early days, and I'm sure you're thinking ahead about that. But you know, rather than every installation that has one has got to have its dedicated person. Part of the reason why, and Carl, it's a point you've often made, lots of now is sitting on the shelf because the person that was interested to begin with has now left, and therefore the robot's not being used. So the more one can build in self-diagnostics and even in time capacity for some limited self-repair, looking to the future, I think that would be a really positive factor.
I totally agree, and especially on the now sitting on shelves, because I have one in my house. She's actually sitting on a shelf behind my desk, so I know what you mean. Yeah, for sure. One of the challenges that we have and that we are working on is being as autonomous as possible, because we know that with Pepper, that's another challenge is that we had. Is setting them up in the morning, at night, and all the logistic that you had to have just for the robot. And so we want to erase all this part and do a robot that is completely autonomous. Of course, there are steps for that. The robot is not autonomous today, but we are slowly paving the way for it to be in the near future. But yes, we do agree that maintenance and diagnostics is one big part of it. I can't announce or talk really deeply about that today. But yes, we are working on it. And again, we are really open to discussions. So if you would like to participate in any way, even in conversations about it or around that, I'd be more than happy to set things up.
Thank you for thinking about it.
Waterproofing and being able to take it outside today, no, especially not on the demo units that we have there. On the new units that we will be shipping next year, no, they are not IPF5 or IPF6. There's no plan today to make them waterproof. There's discussions about that because we had a lot of inquiries about amusement parks and people that make their business, for example, outdoors. But today, we don't have anything in the near future, not enough to talk about this. A customized waterproof suit that might work, and if that's something that you develop, something that you could actually put in the marketplace when it's up. But yeah, great idea.
You will do subdiving Miroka. I hope you're happy.
How easily does lost the question? How easily does Miroka break? I'm gonna do a cop-out answer, and I apologize for that. Again, we don't have that many data, especially on the new robots. So on the older one, at the beginning, a lot, but a lot less now.
Yeah, the damage were caused due to fall most of the time. At the beginning, it was awful, but now we're getting more confident, and the robots are not falling. It's like rare that's happened, and so it's okay. And on the next version, it won't fall to the floor, so it's even safer. And actually, we are working on some torque for the hardware arm, for example. So if the robot feels like it cannot move the arm further, it will just stop to avoid some braking. So yeah, and also in the qualification process, we are trying to do some cycling tests, so to see how the bot can run a distance, see how many times the arm can open, close each time, so we can, for the next version, qualify what breaks or not and what needs to be changed.
And managing that is also a big thing for us, because I don't think I've mentioned it, but we are really ambitious in the number of robots that we want to produce and put on the field. As the goal and ambition is to put 100,000 robots out on the field in the next 10 years.
I think robots
movement
just answered
speed.
Dave's question.
Sorry, does Miroka have a great dense move?
So right now she has some, but later we are working on the new animation engine process. So she will have new animation with more arms movements, and it will be so great. Like she will have, for example, she will have a pose for the pictures, and she will do like a heart with.
Really?
Yeah.
Oh, nice.
But we are still developing that.
One way we do dance today, if you've been to Vivatech, as some of you have, I saw in the chat, you might have seen it, is dancing with the human. So putting the arms like this, so it's the human is leading the actually, we can ask if, do you want to dance?
Better with music.
Yeah, there's no music. I could try to fake it, but I'm a really bad singer. So yeah, it's more of a slow waltz than it is the tectonic dance that now can do at the moment. But yes, we are working on a new animation engine to make new animations and better ones and quicker ones and faster ones also, as the hardware is improving. For example, on the new version of the robots, the arms are still the same strength and characteristic, but they are, I think, 20% smaller, thinner. So we can make more and more animations in the coming month. But yes, I saw a question about the
speed movement.
Speed of movement. I don't know if you know.
3.2 kilometers per hour.
Yes.
Max speed.
Max speed is 3.2. Yeah, KPH. So I in miles again. I apologize. It's like euros. We don't make conversions here in France. So something like 2 point something.
We'll be able to make customized personal. Yeah, I think it's something that we want. For now, we are focusing on 2 characters, so Miroka and his brother Miroki. But I think if you have some custom ones, you can do it by the LLM, and also you can choose to use some expression than other. But basically, what we want is for the Mirokai to be nice and happy all the time. So please don't make a grumpy Mirokai, even if we have animations for that.
Yeah, and to add just a bit to that, yes, one other thing that we want to protect is the we don't want Mirokai to start insulting people, but there's also levels depending on the type of partners that you are. So retailers will not be able to really tap into that, while researchers have a deeper access to even the sensors. So yes, we can tweak the personality today, but to do a full other character, it's also something that we are open to. How many independent fingers? So the fingers are not. I mean, 2. There's the 3 fingers here on the hand are not independent, but you have the perfect timing.
Yeah.
But you have the thumb that is also on the other side. But yes, the way we do it is the fingers are not independent. It's because we don't want to grab everything. We just want to reliably grab the handles. And so for that, we don't need independent fingers. Today, there has been discussions, but today we don't do independent fingers.
Can I just say, and I hope nobody thinks I'm speaking out of turn at this stage, but what we've seen today is incredibly impressive. It's well, I want one already. So there's, and I'm not being funny, as some of you know, I've been knocking around this field for the best part of 14 years. Yeah. So to actually see something new that I just go, I have to have something like that. It's got to be pretty special, because none of the currently announced humanoids have inspired me in that way. So I just think, once again, and please pass my congratulations to Jerome, he's just created something absolutely amazing out of that amazing head of his. Yeah. Mm-hmm. And the fact that you guys have been able to bring it to life is incredible. It's really impressive piece of kit.
Thank you very much for the vote of confidence. I will make sure to pass it on to the whole team. I'll make a quick post tonight. I think that's battery life is starting to Miroka's battery, but mine also. I want to go home. No, I mean, if you have more questions, really, please send them my way. If you have my email, I don't know if we can put it there. Might answer just a last question, but if not, if Dave, you have my email, you can put it in the chat.
Yeah, or I'm happy to take questions via Meetup and forward them on.
Yeah, and so you can send them directly my way. I'll make sure to bother the people that have the answer, because it's certainly not me. But yes, thank you again very much for your time. Thank you, Miroka. Thank you, Maël. Mainly. Yeah. And thank you to all the team that helped me on this.
Thank you.
Yeah, if you have questions, please send them my way. It's been a pleasure. And if you have any, yeah, my email is there. And yeah, if you have questions, please feel free to send me emails any time of the day.
Feel free to ask any questions you have.
Miroka, it's time to say goodbye to our friends. Maybe you can say a last word.
Thank you, friends from Hack Robot. It was enchanting to be with you. Until next time.
Thank you very much.
Thank you very much, and thank you, Maël and Edwin, for. I know you've been staying late, so it's very much appreciated. And Carl, yes, You have to get in line, right? If we're having robots, I'll first in line. Okay.
Yeah, you and me both, mate. You and me both. At least the delivery time frame will be less than Blue Frog Robotics. But I also just want to say, Edwin, very nice to see you again after all these years.
Yeah, thank you, Carl. When I saw your name in the chat, I was like, that's the name from the past.
Indeed.
All right.
Thank you all.
Thanks very much, everyone.
Bye-bye.
Cheers,
Bye-bye.
guys. Bye-bye.
Bye-bye.